Hey guys, another chapter 10 video today, and we are going to work on how do I find compound probability. So that is our essential question today. So go ahead and set up those notes, make them look nice, and go ahead and write that essential question. How do I find compound probability? All right, so first off, I guess we better know what a compound event is. So our main idea today is this word compound. And I'm going to write compound event. And what this is it's when you have two or more events happening. So there's more than one thing happening. You're not just rolling a dice, you're rolling a dice and flipping a coin. You're not just picking out a shirt from your closet, you're picking out a shirt and a pair of pants. Compound events are when you have two or more events happening. Two or more events happening. And what we're going to do is we're going to find the probability of those two or more events happening. So let's try our first problem of the day today. We'll do our first example. Example 1. So we're going to play a game where you're going to be flipping 3 quarters at the same time. So flip 3 quarters. If you can get all heads, you win the game. So flip 3 quarters, all heads, or if you can get all tails, then you win. So you and a friend are playing this game. It's lunchtime. You've decided to flip 3 quarters as many times as you want. If you get all heads or you get all tails, you win the game. What's your probability of winning? What's your probability of winning? How likely are you going to win this game? What are the chances? Your friend says, okay, we each flip one time, go. And if you get 3 heads or 3 tails, you win. What's your chances? So to figure this out, we're going to start with a strategy here. First, we're going to do a tree diagram. What are all the possible options when you flip these quarters? So there are 3 quarters. We'll keep that in mind. And when you flip, remember, you either get heads or you get tails. So the first quarter you flip, and you either get a heads or a tails. The second quarter you flip, and it either comes out to a heads or a tails, or heads or a tails. And the third quarter you flip, and it also can be a heads or a tails, heads or a tails, heads or a tails, heads or tails. So how many options are there? It looks like you could get 1, 2, 3, 4, 5, 6, 7, 8. 8 possible outcomes. So our sample space is we've got 8 possible outcomes. Please write this down in your notes. Write down everything I'm writing down. So our sample space is 8 possible outcomes, but to win this game, you have to get all heads or all tails. So where does that happen? Well, right here when you flip, if you were to get a heads, 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 there's one event, one possible way you could get straight heads, but all these other ways don't work. This is heads, tails, heads, heads, tails, tails. Those options don't work. This one's tails, heads, heads, tails, tails, heads, tails, tails, tails. Here it is. Tails, tails, tails. So how many chances do you really have? I see 2 possible times. So we're going to write probability of all heads or all tails equals 2 chances out of 8 possible outcomes. 2 out of 8. Well, let's divide that down. Divide by 2 here. We'll simplify that fraction down to 1/4. You basically have a 1/4 chance of winning this game. And we all know that 1/4 means 1 divided by 4, which is 0.25. And that is 25%. So our probability is you have a 25% chance of winning. A 25% chance of winning. So not horrible, not great, but not horrible. You have a 25% chance of winning. So with these compound problems, you can't just go, like in the probability problems we did in earlier videos, you would go straight to this step where you'd figure out the probability. But with compound problems, you got to make your tree diagram first so you can actually see what the outcomes are and what are the chances. And so that makes it a little bit different. What if we did this? What if we changed up our game here? Let's do another example. Let's call it example 2. All right, example 2. New game. This game we're going to roll 2 dice. So roll 2 dice. Now, if the game is to roll 2 dice, let's think about the options. If they're standard dice, there's only 6 numbers on a die. So you roll the first dice and you either get a 1, 2, 3, 4, 5, or a 6. I mean, those are really your only options. That's what you get from the first dice. But what do you get from the second dice? Well, the second dice is the same thing. You either get a 1, 2, 3, 4, 5, or 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Those are your options. So that's going to be what you're going to get here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Wow. So how many options are there? There's 6 for each of these, and there's 6 of these. So 6 times 6, there's 36 possible outcomes when you roll these 2 dice. 36 possible outcomes. Okay, but here is our question. Our question is, you roll the 2 dice. What's the probability? What's the probability? Probability of rolling 2 odds. What's the probability of rolling 2 odd numbers, 2 odds? So the probability of 2 odds. Okay, well, we know there's 36 possible outcomes, so we know it's going to be out of 36, but we got to figure out which one of these have 2 odds. So if I roll a 2, that is not an odd number. So I already know that's off. That's not going to be an odd. So if I roll a 2, that won't really affect me. If I roll a 4, that won't help me. If I roll a 6, so I'm at least going to narrow this down. But if I roll a 1, 3, or a 5, that's an odd number on the first dice. So what are my options here? Well, I could roll the 1 and the other 1, so I could get a 1, 1. If I do a 1, 2, it won't work. If I do a 1, 3, so if I roll a 1 and a 3, that would work. If I do a 1, 4, nope, that's not odd. If I did a 1 and a 5, that would work. And a 1 and a 6 would not. So I could roll a 1, 1, a 1, 3, or a 1, 5. Those are my 2 dice. It looks like 11, 13, and 15. I don't really like the way it looks. So picture them each as like dice. So you've rolled your 2 dice. You could get a 1, you could get a 5, you could get a 1 and a 3, or a 1 and a 1. Okay, what about with the 3 here? Well, there's 1, 2, 3, 4, 5, 6 options. I could get a 3 and a 1, so a 3 and a 1. That would work. 3, 2 doesn't, but I could get a 3 and a 3. I could get a 3 and a 5. Those are my options. With the 5, I've got a 1, 2, 3, 4, 5, 6. I could get a 5 and a 1, or a 5 and a 3, or a 5 and a 5. So how many possible ways can I get 2 odd numbers? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 ways I could get double odds. So the probability of 2 odds is 9 out of 36. Let's divide that down. What if I divided by 3? To simplify this down, that'd be 9 divided by 3 is 3. 36 divided by 3 is 12. So why don't we divide by 3 and make this even smaller? And then we'll get 1/4. Wow, look at that. You actually have a 1/4 possibility of getting 2 odds. So the probability of 2 odds is equal to 1/4, which is kind of similar to the last problem. That is 25%. You have a 25% chance of getting 2 odds. So not as bad as I was picturing different. So yeah, not too bad. So 25%. So we're going to write, you have a 25% chance. You have a 25% chance of rolling 2 odds. So that's going to kind of wrap up our video for today, but compound probability is basically this probability where we've got 2 or more things happening. You're rolling 2 dice, you're flipping 2 or 3 coins, you're picking out shirts and pants in your closet. I can make up a lot of examples, but you're doing 2 different things and you're trying to figure out what's the probability of those lining up in a certain way. So like, what's the probability of rolling 2 odds? Or what's the probability of flipping 3 quarters and getting all heads or all tails? And so that's kind of what compound means. And we will practice in class for sure. I hope this made some sense, and sorry for the messy handwriting in this video, but sometimes it happens. All right, bye guys.